Okay, actually, regarding this network defense unit, let's start from the beginning. Uh, we have to be aware that there are network issues and we are going to face. When we said that the context of the subnetting is one of the first approaches to go beyond in order to secure a network, it is because of the size of the network and the let's say the conflict and the mess that we can face inside the network. So the subnetting is one of the advancements and the solutions, the countermeasures, troubleshooting for troubleshooting, sorry, and things like that. So we have to face an issue in order to talk about a suggested solution, no more, no less. Okay, I'll be passing through, and if you actually find any issue in any point, you just declare. Otherwise, I'm passing very quickly. Yes, demilitarized zone. We explained the demilitarized zone with the two architectures, whether we are using a one firewall or a two firewall based architecture. The differences are actually is that for the two firewall based architecture, the demilitarized zone has to be accessed by all visitors to the network. Otherwise, they would not be able to access the network. Here, for the one based firewall network, the administrators or the authorized parties they can access the network without visiting the demilitarized zone. Um, for the for two firewall based architecture, there have to be an entry to the firewall to the demilitarized zone before accessing the current network or the servicing network. Nothing is one of the contexts that we may face also for securing entities, not networks, entities by hiding their ID to the external world. Network address translation is a scenario that we find it. It's a process, it's an approach, it's a mechanism that we find it on the perimeter of a network to hide the internal IP addresses from the external environment. How to hide? By giving a mimic IP or a simulation IP or let's say custom IP or let's say a falsified IP and to be related to the original IP. External members will see only the fake one, the mimic one, and the real one will not be visible. So the context of this approach, this nothing, the net address translation, it's a matter of replacing the original IP with an alias IP, let's say, with represent an IP or represent an IP as an alias IP. So the external world will see the alias, will not see the original IP. And every communication from the external world we may talk about, not only, but we may talk about the public networks like the internet. Uh, any communication to you, for example, any computer, the device responsible for setting the nothing will match the destination wanted from the, let's say, the message coming from the external world with the real IP address, and it will direct the communication to there. Preview here, original IP address, a mimic IP address, and this is the external world. Every communication from this device here, and suppose that you have one device, but if it is a list of devices, a local network, all they would have actually real IP addresses, and all they would be actually having an alias to their own IP addresses. But for one computer, so one real IP and one alias. The external world will see the alias, will not see the real IP address, alias. And any requests or any submissions from this device to the external world will go with the alias to the external world. The real IP address will remain here in the device where the nothing is activated. We may talk about the router mainly. The router is the one responsible for activating the NAT service. The vice versa, any communication from the external world to this dedicated device, the communication will be sent to this alias, not to the real IP address. And there is no computer in the local network has this IP address. The same device who matched the real IP with the alias, he would match the vice versa, the alias with the real IP address, and he will direct the communication to the designated device, to identified device. From the same concept as we have actually network address translation, we have a port address translation. Network address translation, we talk about the IP address. Port address translation, we talk about the ports. What's the difference? The difference is that on top of the same IP address, we would have a list of ports to be utilized for a list of services. And each service has to be identified with a port. Otherwise, there will be a conflict or an issue to deliver the services. So the ports here, they would be matched in the same scenario. The real ports, they would be matched with an alias port. Usually the same scenario. The perimeter device, similarly, we talk about the router only, would do the task of matching the real ports with the alias ports, and the vice versa also. If any requests come from the external world to the internal world, the alias port would be matched with the real port. But remember, we are talking about the services on top of the same IP address. List of ports to be reached or to be communicated, to be utilized, to be, let's say, discussed, or let's say whatever, used on top of the same IP address. Another security mechanism that we find it to be considering or to be actually delivered on the computer networks, the NAC, Network Access Control. This NAC, or this Network Access Control, as per the, literally speaking, the access control means it's a process, it's an approach, it's a mechanism via which also the perimeter device and the network would allow or deny requests, whatever the request is. Here we are not talking about the NAT or the PAT, network address translation, or the port address translation. No, we are talking about a filtering to either allow or deny access or requests to be passed. And this access control, or this network access control, it works how? By just setting a group of politics to designate the criterions, who is allowed to access and who is not allowed to access or to pass. So based on a group of conditions, constraints, they specify the criteria, whether allow a device or to deny it from accessing the environment. As per the, literally speaking, the definition of the NAC, it is a matter of filtering the packets or the frames passing from a network to another, from a perimeter to another, from a trunk to another. So whether you are allowed to pass from this range to the other one or no. So that is the aim of the methods for let's say uh, implementing such a scenario. We may use the available protocols, which are the DHCP or the ARP. They are DHCP or the ARP. There are two protocols. Let me just highlight them. Yes. Okay. Actually, methods for implementing such a filtration via which we are going to, for example, deny and to pass. Deny, what does mean deny? Are we going to delete the request? No, the request is already received. So what should we do? The request has to be actually either put into a quarantine area or pass to the destination. Who would do that? Actually, two protocols that can help in doing so: the DHCP domain host control protocol or the ARP, the address resolution protocol. Those scenarios, those two protocols, they can help in filtering requests and passing it to the quarantine area or to the quarantine zone. The device is responsible for implementing the NAT, the PAT, or the NAC, network address translation, port address translation, or network access control. They are numerous, and the differences are actually based on the user interface list of functions or functionalities, front-end functionalities that actually to bring the life to an easier state. Other than that, they are a matter of, let's say, producer or procurer or manufacturer. So there is no distinction between this and that. The interface or the experience to be given by the front-end interface makes the difference in between the network devices to be utilized for the access control, for example, to implement the access control. So we go, for example, I give you two very famous for us here devices that we can refer to in order to implement the network access control. The Microsoft devices, whatever, any server or any dedicated device, or Cisco devices. Which one you prefer? So here, it's a matter of, let's say, preferences. The preferences you draw them based on the functionalities to use or the functionalities delivered by each device. So choosing this or that, it's not a matter of technical expertise here. No. Cisco, Microsoft, let's say Juniper, Trust, any third-party company. Okay. For the concern of putting actually, or let's say, send in a request to the quarantine zone, it is after the filtration. So actually, step number 5, which is the last one of a request, let's say here, passing through the different phases, it would be put into a quarantine. Otherwise, it will be actually passed to the destination. Any request has to match the technical and security measurements mainly talk about the digital certification and the digital signature, health certificate. So there have to be actually a health status to match when a request is being submitted. Otherwise, from the beginning, we don't talk about the rest statements. And along with the step number one, to pass to the step number two, there have to be actually the status or the state of the art of this, let's say, device or mechanism or whatever this transmission has to be submitted with statement of health or this the art of the state of art, whatever, to indicate what is the status of this device. Step number three, actually, the health certificate has to be actually generated from the mechanism, from the scenario, and this health certificate would be matched with the actually these health certificate sent by along with the request. If matched, okay, and there is no issue in it, so destination will be reached. Otherwise, if it's not if it's not healthy, it means there is an issue with the health certificate sent by client. It is saying statement, I know, but whatever the status declared by this user, if it's not matching the required status, it would be put into quarantine. After what? After the filtration here. Terminology is actually to make us understand more the network defenses. Every single service delivered on a network has to have a terminal to be actually, let's say, utilized. For the client or clientless actually variation, it's a scenario via which we see the service delivered to the end user without the need of the dedicated client. In the sense of uh, you cannot open a www unless you refer to a web browser in order to just validate your request and you access the needed resources. So the client, the www browser, what you are going to use to open such a destination, is a client. But the meant here of the client in our concern here, network security, is not the browser as per the terminology. We are talking about plugins and add-ins that they need to deliver services, and those plugins and add-ins they need to have a representation in the front end part. Example: ActiveX and Java. Those are products. Those are actually tools that we can use to create solutions. Take the example of the ActiveX. It's a Microsoft library that holds predefined and let's say predefined, yeah, methods for different purposes, for different tasks. Okay, the switch and the inline or out of band, sorry, mechanisms, they are SNI, they are terminology, they are variations. We can face them when the NAC is in action. The network access control is in action. So the network access control is not only routers to use to yes, to draw this process or to activate this process, because switches layer number 3 from the OSI model that do the same, they can do the same capabilities and maybe even better because they are dedicated for such tasks. The switch is the layer number 3. An inline process means actually it's an process to be coming actually from a device which is um, holding all the traffic, accepting all the traffic, or all the traffic is routed to destination through that peripheral or that device. Out of band, in the sense of the capacity of processing a stream is less than the stream received, or is less than the stream process. Pre-connect or post-connect, those variations actually which we see the NAC requires a device to be filtered to pass or not, to pass his requests or not, before actually the filter, it would be actually yes, the decision to be taken before passing any request. Post connect, it is the same scenario. The test would happen, but still even after the first communication and the second communication, the filtering will remain going on. Means the NAC will not stop after setting up a first scan. If it's validated, so all the other requests from the same client, from the same computer would be actually accepted later on. No. For the post connect, no. For any request, there will be a new scan, a new filtration, whether it is accepted or not. Pre-connect, it is only one filtration. To be happening actually at the beginning of the first communication. Network defenses based on the use of the third-party appliances or security solutions. I believe that we are familiar with some of them. Some of them we defined across our chapters, across this course. And you may know some others from your daily life. But we are going to explain them one by one. Sorry. So in all cases, those are actually third-party applications. In all cases, those are third-party applications, those third-party solutions dedicated to security, digital security only. Starting with the firewalls. Starting with the firewalls. Those are actually a sort of a filter, packet filter based solutions. Packet filter based solutions, what does it mean? They would filter the packets transmitted over the network, or the dedicated network, and to allow to deny based on list of criterions also. And this filtration would be done by either a software application, or a hardware, which is also playing the role of a filter. In our cases, those are firewalls. And when we talk about the hardware-based, let's say, firewall, it's like a server, for example. It would be actually put into within the perimeter of the network, not inside. It means it has to be actually an interface with the external world. Yes. So this is an example of a firewall and the perimeter of the network. What does mean perimeter? Means what it comes after is only the public network. What comes before, it's the local network, the dedicated, the considered network to be secured. There are scenarios how this firewall works, technically speaking. So basically, we know that the firewall now so far it's a context of packet filtering process. Means the packets bypassing or transversing, or let's say trespassing the layers of the security set. This is the normal, or this is the abstract definition we can give to a firewall. But technically, there are actually some hidden details that we have um, to recognize. If the firewall is based on the group of politics, let's say policies set by the administrators or the technical people or whatever, rules, policies, whether to allow, to deny. Okay, Fulani is not, the computer number one is not allowed to send any requests from A to 4, for example. So this is a rule, this is a policy. Software application tell is not allowed to submit or communicate any requests from A to 4, for example. This is another rule. So based on group of policies, rules, the firewall would run. So we are talking about stateless packet filtering here. So at the end of the day, it's the packets only to be blocked, no? Whatever the packet content. But based on what? Based on group of rules, policies. There is no state to check. There is no state to check. The second scenario, the second category of the firewall, let's say, behavior is based on the state. Means there have to be actually a recognition by the firewall. Here we can see that if a computer has been validated today, tomorrow it would pass. Why? Because the firewall memorizes sources and destinations and memorizes the state of a packet in order to allow it in the future or to deny it in the future. So this memorization is a record to be kept by the firewall itself. Beside of that, and moreover than that, actually connections and connectivity have an influence on the firewall decision. It means the type of the network, if it is wired or wireless, it might have an influence on the firewall to decide either to pass or to allow to pass the received frame or packet or not. Every single firewall would have to check a source of a request, the destination of a request, and a port which is a service. A port which is a service. This is an example of a port 80. The 8080 port is the HTTP protocol. It opens the internet. This is an example only, the firewall, the 8080. This is for the stateless packet filtering. This is for the stateless packet filtering. This is for the example of the stateless here, based on the group of rules. Only source and destination and the service. Source and destination and the service. So the rules will decide source address is blocked or is allowed. Destination address is blocked or denied. Port or service type is allowed or denied. For the second scenario, which is the stateful, not the stateless. there will be actually another scenario, which is to check the connectivity. Yes, but beside of the yes, the rules that can be utilized yes, to filter the requests and the submissions or whatever, there will be a checkup here to check whether the source has requested efficiently and effectively and truly the request, or it's falsified. Is it a device redirect process or not? So it is a security to be checked also. Here, it's not only source and destination and the serves, but also there is an interference here to check whether the destination is, sorry, the source has requested, and another context, which is the destination, where it is available, where it is located. Yes. Good. Firewalls actually, they are actually software application that they might be installed on top of a one device computer, not only to be uh, on a network only. There are versions that they can run on a standalone computer. Those are from the benefits of the firewalls in plural. Yeah. So the policies that they actually rule a firewall is the list we are going to define right now. The Active Directory can be actually controlled by a firewall. In the sense of a firewall can be configured to adopt the Active Directory services. Yeah, so the Active Directory, it is the location where to define the list of computers and the list of users inside the network. And those users and computers, they might be actually controlled from the Active Directory only. Yes, using a firewall, absolutely true. The firewalls, as per the stateless filtering, it is to be working on top of the source and destination IP addresses. So allowing and denying local and destination IP addresses, that might be using the two protocols, the DHCP and the DNS. Firewalls also can run on top of filtering any packets from a dedicated list of IP addresses. Not only in the open, any IP address can come and later on we filter. No, it can work from the other side, also from the other perspective, is by allowing a list of IP addresses only to send requests. Only a list is dedicated and is allowed. And it can run actually for controlling source and destination for two different platforms: the wire-based connectivity and the wireless-based connectivity, using the TCP protocol wire-based and UDP protocol wireless-based. The configuration here, configured, is in the matter of, is in the sense of either allowing or denying, either allowing or passing to the quarantine area. All services, they might be also filtered, not only identities or user identities. sender and receiver identities, but also services. They might be actually controlled. Firewalls also can be actually adjusted to match specific, let's say, ports, or let's say specific applications, specific interfaces via APIs, means in software applications at the end of the day. Because it will not see only the interface as a web, but it will see the interface and the software application used. Services as per the ports, since the ports might be actually controlled, also the service can be controlled. Any questions at this level, please?
No, Mr.
Okay.